Welcome viewers. In this video we'll see the work done followed by potential and potential difference. First we'll see the work done. So work done is nothing but a charge is Q is kept at the electric field that will experience a force in the direction of electric field. If you place a charge in the electric field, what will happen? The force will be developed on the charge. By referring this diagram, here the charge is available. This plus minus is the electric field. This is nothing but a electric field. In that electric field, charge is placed. So due to this electric field on the charge, the force is created. Force is developed. That is called F. On opposite side, we are having applied force, Fa. Force is applied on the opposite side. Electric field is available. Charge is placed. Due to electric field, this charge experiences a force that is nothing but F. On opposite side, we are applying one more force, Fa. If both are equal, then the charge will be remain in the same place. Suppose if Fa is greater than F, what will happen? The charge will move from this point A to point B. Right? If Fa applied force is greater than the force developed, mean the charge will move from the point A to point B. So what is the force applied and what is the distance moved is nothing but a work done. Right? Fa dot dl. So this description is given. F is the force experienced by the charge Q. Fa is the force applied on the opposite direction. If magnitude of Fa is equal to F, they remain same place, equilibrium. If Fa is slightly greater, then the charge will move from A to B. So the small work done by moving the charge is nothing but Fa dot dl. Very simple. So we are applying the force Fa. The charge is moving from one place to another place. That is called dl. So Fa dot dl is nothing but the work done by the charge. Fa dot dl. Right? So the total work done in moving a charge from A to B can be obtained by line integration. So this is due to only small length. The total work done can be obtained by the integrating on both the sides. We will get the total work done. So work done equal to integral A to B Fa dot dl. Right? A to B is the 2 points. In between A and B only the charge is moving. This is the applied force into dl. But F and this Fa is equal and opposite to the force developed. That is Fa equal to minus F. So that we can replace this Fa as minus F. Right? Now this is the applied force. Now it is replaced with the force developed. Fa and F are equal but in opposite, negative. So that minus Fa dot dl. But E equal to F by Q. Electric field intensity equal to force divided by charge. So cross multiply this. Force equal to electric field into charge. F equal to EQ. So that we can replace this F as E into Q dot dl. Right? Now the force is replaced with electric field intensity and charge from this relation. So finally what we got? Work done equal to minus. You bring this Q outside. It is a constant. Minus Q integral A to B E dot dl. So the general expression for the work done is nothing but minus Q integral A to B E dot dl. Right? Now we'll see the potential, electric potential. What is the definition for electric potential? Is also called as absolute potential. Is defined as the work done in moving a unit positive charge. Right? Work done in moving a unit positive charge from infinite to the field point. Absolute means it is from infinite to the field point. We are going to move the charges, positive charge, from infinite point to the field point. Right? So the work done in moving a unit positive charge from infinite to the field point. Now we'll first write the work done. What is work done? Just now we discussed minus q integral a to b e dot dl. Work done is nothing but minus q integral a to b e dot dl, right? Now bring this charge in the denominator, so that work done divided by charge equal to minus integral a to b e dot dl, right? Work done by charge, what is the work done by the charge? From the definition it is clearly given, work done in moving a unit positive charge. So work done by charge is nothing but potential V, right? So the potential V is nothing but work done by charge. So that is equal to minus integral a to b e dot dl, right? Work done by charge is potential, work done in moving a unit positive charge, so that this can be replaced as potential. Now we will replace this E as q divided by 4 pi epsilon x square into dx, right? With a limit of a to b. Q, it is a general formula, q divided by 4 pi epsilon x square into dx. Here we are having x, so here also dx. So this minus q divided by 4 pi epsilon is constant, only we have integral a to b 1 by x square into dx. These terms are constant. So minus q divided by 4 pi epsilon, integral 1 divided by x square is nothing but minus 1 by x, that you know that it is minus 1 by x. And what is the limit for this? It is nothing but work done in moving a unit charge from infinite to the field point. One is infinite, another one is the field point. So the limit is infinite and another point is r, right? It is clearly given in the definition, infinite to the field point. Now we'll substitute the limit minus q divided by 4 pi epsilon. Here minus is there, minus 1 by r. Here 1 minus, in the lower limit 1 minus will be there, so it becomes plus 1 by infinite. So it becomes 0. Here 1 minus is available, here also 1 minus available. So q divided by 4 pi epsilon r. So the electric potential, the general formula is q divided by 4 pi epsilon r. Now we'll see the potential difference. What is potential difference? It is defined as the work done in moving a unit positive charge from point B to point A. Absolute potential means infinite to the point, field point, from infinite. But here potential difference is there. That means difference between 2 points, point B to point A. Same thing, work done in moving a unit positive charge, but it is from point B to point A, right? It is clearly given. So potential difference VAB, right? VAB refers means the potential difference between A and B equal to integral a to b e dot dl. Normally b to a, one negative will be there, that is replaced by exchanging the limit a to b e dot dl, right? So directly we have got this expression. Now replace this E as q divided by 4 pi epsilon r square into dr. Here we are having r, so that it is given as dr, right? Now this q divided by 4 pi epsilon is constant, only we have integral a to b 1 by r square into dr, right? Other terms are constant. So q divided by 4 pi epsilon, the integral 1 by r square is minus 1 by r. Now what is the limit? Ra to Rb, because point A to point B, that is clearly given, so that we are taking Ra Rb. Now substitute the limit q divided by 4 pi epsilon minus 1 by Rb plus 1 by Ra, right? So minus is there, while substituting the lower limit it becomes plus. So we will rewrite this, so that q divided by 4 pi epsilon into 1 divided by Ra minus 1 divided by Rb. That is the potential difference between the 2 points A and B. The points are represented as Ra, Rb.